So here we have a scale in newtons that we use to measure the force on an object that we hang from this hook. So this object here has 500 grams, and because it's constantly accelerating towards the center of the Earth, or it wants to accelerate at 9.81 meters per second squared, if we hang it on this hook and it is motionless, then we know that the force of tension here is equal to the force of gravity that wants to pull it down. And we can use that knowledge to measure that force in newtons. So here we see that it is a little less than 5 newtons, which is to be expected if we use the acceleration 9.81 meters per second squared and use the formula F equals ma, where force equals mass times acceleration.
Ready? I'd say like 10.6. I'd say like 12.5, yeah. So this is a frictionless cart. We placed it on the track here to kind of compare how mass affects the acceleration of a heavier object. So these magnets right here apply a constant force to the cart. So if you line it up here and let it roll, you can measure the time it takes for that. And this distance, the scale right here is in centimeters. So it's probably good.
So if we take a look at the second example, where we have a 500 kilogram cart traveling a fixed distance, and we measure the time it takes to travel that fixed distance, we can find the acceleration with this basic kinematic formula right here. We will cancel out the variables that we know to be 0, and we'll find that the acceleration is equal to 2 times the final distance over time squared. And we plug everything in, we find that the acceleration is equal to 0.602 meters per second squared. However, if we use the same dimensions and we add a little bit of weight to the cart, say 800 grams, we found that the time it took to travel the same fixed distance was much greater. And if we use the same formula from before, we find that the acceleration is equal to 0.114 meters per second squared. And if we look at this data here, we can see that the force increases as mass increases. However, the acceleration decreases as the mass increases.